Okay, so today we're going to be talking about the law of cosines, but before we get into that, I want to do this warm up here that's dealing with the law of sines that we did yesterday. Now, what I'm going to do in this today is I'm going to kind of show you a little shortcut on the way we did this yesterday. Yesterday we did all this by hand, and I'm just going to kind of show you a shortcut. So on this one, okay, from the 80-degree angle, I can see that the opposite side right here, this X, those are going to be the two that match up. And then from this 40-degree angle, the 12 is its opposite side that matches up. So if I set that up in the law of sines, remember the law of sines is sine of angle A over side A equal to sine of angle B over side B. Like that. Okay, so I'm going to go sine of 40, okay, is to 12. As the sine of 80 is to the side we're looking for, to that side where the X is. So we're going to type this into InSolve. So the way we do that is we push menu 3-1, and it's going to bring up this deal that says InSolve. And then we're going to type in this proportion. So I'm going to go Control Divide, and I'm going to type in sine of 40 over 12 equals sine of 80 over X. Now the one thing you got to make sure is at the end, make sure you put comma and then whatever variable you've used in here, we've used X. And so we're going to get 18.39. Okay, 18.39, whatever units that is. Okay, the second one. All right, now I can see I've got this 84-degree angle and this X that is opposite it, but the problem is I don't know the measurement of the angle that's opposite of this 16 right here. So that's easy enough to find though, is I know these three angles add up to 180, so if I just do 180 minus 34 minus 84, and I'll just type it in here real quick, 180 minus 84 minus 34, that is 62. So this angle right here is 62 degrees. Okay, so now I know the angle that's opposite that side. So now just plugging this into law of sines, it's going to be sine of 62 over 16 equals sine of 84 over X. All right, then from there I'm just going to type that into InSolve. Okay, menu 3-1. So I'm going to go sine of 62 over 16 equals sine of 84 over X. Okay, and remember to finish with, whoa, So we're going to have sine of 62 over 16 equals sine of 84 over X. All right, and remember comma X. And so it's going to be 18.02 on that one. Now in this last one, it's looking for the measurement of the angle. It's looking for angle N. So we're looking for this angle right here. So I can see the side opposite it is the 5, and then the 50 opposite is 7. So I've got everything I need there. All right, so I'm going to start off with this. The sine of the 50-degree angle over the opposite side 7 equals the sine of the angle we're looking for, which is X, over the 5. Now again, I'm just going to use InSolve here. And again, I don't like InSolve, but like especially on ACT, remember ACT, the worst enemy you have is time. And so if you can do stuff like this on an ACT, definitely do it and save the time. Okay, so we have sine of 50 over 7 equals, all right, sine of, and I'm going to put X in there because that's what we don't know, over 5, and then the comma X. And so that is 33.17 degrees. 33.17 degrees. Okay, So, like I said, today we're going to talk about the law of cosines, which the law of cosines is totally different than the law of sines. But it's useful for different situations, and we'll see that. But okay, so the law of cosines, and same thing, kind of have a mess here. I should have really cleaned that up, but that's the law of cosines. So it is a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And yes, I know, that is a mess. But it is what it is, and as we plug it in, you'll see it'll work out pretty easy. Now, there's several things to notice here. All right, there's A, B, and C. The lowercase a, b, and c refer to the length of the sides. This one uppercase letter is the measurement of the one angle that we'll be dealing with. And also remember, this is like in the law of sines. This lowercase a and this uppercase a are related in that this angle is the one that's opposite of this side right here. So like over here, you can see where angle A is here, and you can see side A. So that's the main thing to remember, that this side and the angle over here are the two that are opposite of each other. All right, so what we're going to do is I'm going to go ahead and just drop down to number 6 down here, and we're just going to plug it in. So I'm going to first write the law of sines. A squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. So I'm just rewriting what we have up there just so I can refer to it real easy right here. Now, on number 6, you can see it says to find the length of EF. So this is where the X is going to go. We're looking for this side. And that's good because I have the angle that's opposite of that. So what's going to end up happening here is this is the angle I'm dealing with. So it's going to be like this A right here. And the lowercase a that's over here by itself, the one that's on the other side of the equal sign, is the side opposite of this angle. So that's going to be this. So within the law of cosines, this side right here is going to be the A, and then the B and the C don't really matter where I put that. B and C here, I could put B here and C here. Those aren't going to matter. What does matter is that I get the A in the right spot. So I'm going to be putting an X for A, I'm going to be putting 9 for B, I'm going to be putting 10 for C. So I'm going to plug all that in. So I'm going to have X squared equals 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine of 43 degrees. So all I'm doing is just taking this X, 9, 10, and 43 and plugging into its spots. The A is the X, the B is the 9, so it shows up here, and the C is 10, and then the angle is that 43-degree angle. Now, from here we could solve this probably fairly easily, but the algebra on this does kind of get a little bit messy. So again, we're going to use insolve on this, and again, I don't like it, but it definitely speeds this up, and it just helps you to understand the law of sines and law of cosines instead of getting lost in the weeds of algebra on this. So anyways, we're going to plug this in. So I'm going to go menu 3-1. Let me brighten this up a little bit. Okay, and I'm going to type this in. So we're going to have x squared. I'm just typing this in exactly like this. X squared equals 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine now of 43. And remember, we're going to have to finish this with comma x. All right, and I'm going to push enter from there. And you can see it's 7.025, so we'll round it and say 7.03. This is 7.03 centimeters. Okay, number 7. Now on this one, we're looking for angle X. So here's angle X, so I'm going to put an X on angle X, I guess. Now remember, in the law of cosines, the angle here is opposite of this side that's over here. So as I think about this angle, okay, I have 6, 7, and 8. Which one of those three is opposite of this angle? Obviously, it's the 7. So the 7, since I'm looking for this angle, dealing with this angle, the 7 is going to be the one over here by itself. It's going to be the A. So the 7 is going to be like the A, and then the 6 will be the B, and the 8 will be the C. Okay. And then obviously the x is going to go where the angle is, because that's what I'm looking for on this one. So on this one, it's going to look like this. 7 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of the angle that I'm looking for here of the x. All right. So here we go. Menu 3-1. And again, the way I'm doing that is you push menu 3-1, brings up this insolve, and then I'm going to type in 7 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of x, comma x. Remember, you have to finish off with that comma x. If you don't finish off with the comma x, you're going to get an error like that. So make sure you finish off with the comma x. It has to be inside that parenthesis. Inside the very last parenthesis, it has to be inside of that. So it's going to be like that. So you can see that's going to be a 57.91 degree angle. All right. 57.91 degrees. That's how big angle x is. All right, number 8 says to find angle R. So here's angle R. Now on this one, if I'm looking for the angle, I'm going to have to know all 3 sides. And so what's going to end up happening on this one is I'm going to be able to use law of sines, which if I can use the law of sines, that's always going to be the little bit easier one to deal with, I think anyways. So on this one, we could set it up to solve for the law of sine. So the sine of 95 over 21. So the sine of 95 over 21 equals the sine of the angle we're looking for over the 15. And you could type that in to insolve and just let it solve that for you. Okay, I'm not going to worry about that. So let's go ahead and look at number 9. So on this one, AB. So we're looking for this side right here. All right, since I'm looking for the side and I have the angle opposite that, that's what I need right there. Okay. So since this is the angle I'm using, this is the opposite side, this is going to be the A. This is going to be the one by itself. So on this one, it's going to be, okay, x squared equals 11 squared plus 16 squared minus 2 times 11 times 16 times the cosine of that 28 degree angle. All right, and so I'm going to type this into insolve. So I'm going to go menu 3-1, x squared equals 11 squared plus 16 squared minus 2 times 11 times 16 times the cosine of that 28 degree angle. Remember, finish it off with comma x. And it's going to be 8.136, so 8.14. Kilometers. All right, let's flip it over. Let's just look at 2 more here on the back real quick. So on this one, I'm looking for YZ. So that's the side that I'm looking for. I have the angle opposite, so that's good. So this is going to be like the A, B, and C. So on this one, I'm going to go x squared equals 4 squared plus 7.6 squared minus 2 times 4 times 7.6 times the cosine of that 52 degree angle. All right. So menu 3-1. x squared equals 4 squared plus 7.6 squared minus 2 times 4 times 7.6 times the cosine of 52. Finish that off with the comma x to find out what that is. And it's going to be 6.027, 6.03. All right, so 6.03 feet. It's going to be the length of that side. And again, on all of this, you can always just check for reasonableness of answers. Okay, if this is 4 and this is 7.6, does it make sense for this to be 6.03? Yeah, it does. But if you get something like 500, or if you get something like 0.004, that doesn't make sense either. So just make sure that it makes sense. And that definitely is reasonable. Okay, let's drop down and look at number 19, where we're looking for an angle on this one. So on this one, we're looking for angle I. Looking for this angle right here. Okay, so then obviously the side that's opposite of that is this 74.2. So this is going to be like the A. So we're going to go 74.2 squared equals 43 squared plus 35 squared minus 2 times 43 times 35 times the cosine of the angle I'm looking for, x. So we have a squared equals b squared plus c squared minus 2 times b times c times the cosine of that angle. All right, and then from here, go menu 3-1. All right, 74.2 squared equal to 43 squared plus 35 squared minus 2 times 43 times 35 times the cosine of the angle that I'm looking for. Make sure I got that all typed in correct. Yep. All right, finish it off with the comma x. And 143.89 degrees. And I mean, that's reasonable. Definitely an obtuse angle. And those numbers look like they could be legitimate with the way it's drawn. So this is like 143.89 degrees.